Hello students, welcome to my next video. We are done with the different types of functions under the non-homogeneous linear differential equations for phi of x. Okay, so now the next concept is to find the solution of a second order differential equation, ordinary differential equation, by using a different method. The name of the method is method of variation of parameters. And you guys have to apply the same method if it is specified. We cannot change the name of the method. If it is specified variation of parameters, you should use variation of parameters only. Okay, you cannot use anything else. That is the thing. Alright. Okay, so what is the name of the method? Method of variation of parameters. Understood, guys? So let us see what does this method say and what is the procedure of the method, and based on that we can solve a few problems. So let us assume an ordinary differential equation, specifically second order, which is in the form of f of d into y equal to phi of x. F of d, you know this, right? This is the second order. This will be a second order differential equation. So f of d will be a second order polynomial in terms of d. So using f of d, you can find CF. How? By applying the auxiliary equation, by replacing d by m and obtaining the auxiliary equation, and hence solving the auxiliary equation to find the values of m. Using the values of m, you frame the CF, and the CF for this equation in the second order only will be usually in this pattern: C1 y1 plus C2 y2. Okay, so that is the general pattern which I have given here, where you know C1 and C2 are constants of integration here, and to find the solution here in this part, in this method, we are supposed to find till CF it is the same. Where does it change? Only the later part changes. And once you get the CF, you should replace C1 and C2, the constants, by assuming two functions. What are the functions here? A and B, where A is a function of x and B is a function of x. Okay, so we replace C1 and C2 by A of x and B of x, and hence our final solution, that is called as a complete solution, we can be obtained, which will be in the pattern of y equal to ay1 plus by2. So now what you should do? You have to identify going ahead what is this a function of x, and what is the b, the function of x. For that we have a couple of formulae that we can use here, and then apply integration, and hence we can identify what are a and b in this particular case. Understood, guys? So what is the further procedure to find a and b? Let us see here. You have to remember the procedure. You will have a couple of formulae. You got to do some problems in one stretch, then only you will have to get the hang of this, and the formula also you can remember. Understood? So what is that? See, first you know what are y1 and y2, right? So using y1 and y2, first find the first order derivatives of these two, y1 and y2. y1, y2 can be either e power x, or in terms of cos A and cos B, cos A and sin B, or e power x, e power A, something like that. Depending on the rules of the auxiliary equation, you will get y1 and y2. Okay, once you identify what are y1 and y2, you got to find the first order derivatives of y1 and y2, that is y1 dash and y2 dash. Using y1 dash and y2 dash, we can compute a quantity called Wronskian. W stands here for Wronskian. Okay, this quantity can be computed by using this formula. What is this formula? y1 y2 dash minus y2 y1 dash. Substitute the values of y1 y2 and y1 dash and y2 dash in this values or the expressions. Simplify and you get a value for w. Simplify. The simplified w will be used further in finding a and b. Understood? Understood? So after getting CF, replace C1 and C2 by A and B. Using y1 and y2, find Wronskian. Okay, using Wronskian we can find A and B. For that we again have a couple of formulae. Look at this. we have a dash is equal to minus y2 phi of x. Phi of x is the right side part, RHS of the given differential equation, divided by our Wronskian here, that is w. Similarly, b dash is y1, this is positive, a dash is negative, b dash formula is positive. Okay, so y1 phi of x divided by Wronskian. Understood? Once you get a dash and b dash, integrating on both sides with respect to x, we get a and b. Thus, you find the values of a and b, put it in this complete solution. Hence, our final solution will be in the form of a y1 plus b y2. Understood? Which is equal to y. So, this is the procedure. Let us now go ahead and solve a problem so that it is more and more clear for you guys. Alright? So, let me consider a question here, a simple problem, and the question, in the question specifically it will be mentioned, solve the following differential equation using the method of variation of parameters. Guys, you have to compulsorily apply method of variation of parameter when it is specified. You can't apply any other types at all. The types will not come to the picture when it is specifically mentioned method of variation of parameters. Understood? Yes. Let us solve now. Consider a question that says solve d square y by dx square plus y is equal to secant x tan x. It's a product of two functions using specifically mentioned there. See, method of variation of parameters. Method of variation of parameters. Okay, so this is the question and how are we going to solve this? So let us see here. First, you have to find your CF as I told you. So solution says to find the CF, let us write it in the operator form, that is d square plus 1 times of y is equal to secant x tan x. What is our capital D here? Capital D is equal to d by dx. Okay, next auxiliary equation which says m square plus 1 equal to 0, that is m square is minus 1, therefore m is equal to plus minus under root of minus 1, and we know that plus under root of minus 1 is nothing but I. Hence, what will be our YC? So, our YC will be this is complex roots, therefore no real part here. C1 cos AX, A is the coefficient of I here which is 1. So, C1 cos X plus C2 sin X. This is our complementary function and you guys know how to find the complementary function in the previous case, and this is same till here. Now, what we will do? Let the complete solution, we will assume here, complete solution B, y is equals to, instead of C1 and C2, we assume A of x cos x plus B of x sin x. And in the further procedure, you got to find what is A and what is B. That's what it is. Understood? So, what is our y1 and y2 here? y1 is cos x, y2 is sin x. Therefore, y1 is equal to cos x implies y1 dash is minus sin x, and hence y2 is equal to sin x implies, find the derivative, first derivative, y2 dash is cos x. Now compute Wronskian. W is equal to, what is the formula for W guys? W is equal to y1 y2 dash minus y2 y1 dash. Substitute the values. y1 is cos x y2 dash cos x again minus y2 is sin x into y2 dash which is y1 dash which is minus sin x. So when you multiply you get cos square x minus of minus is plus sin square x, that is equal to 1. So in this case our Wronskian is 1. Understood? So once you get Wronskian, what is the next step? We got to consider the expressions for a dash and b dash. A dash is given by minus y2 phi of x divided by w, that is Wronskian. Similarly here b dash is equals to y1 into phi of x divided by w. What is phi of x in this particular given question, guys? That is the RHS of the given differential equation, secant x tan x. So substituting y2 phi of x and w here, what do we get? y2 is nothing but sin x, so minus sin x into the phi of x is secant x tan x divided by 1. Okay, now integrating a dash with respect to x, we get a. Okay, so now integral of minus, substitute, put it everything in terms of sin and cos, we get, otherwise we can take a step, that's okay, no issues. Sin x, secant is 1 by cos and tan is sin by cos dx. Okay, so this becomes minus integral sin square x by cos square x dx. This can be written as integral 1 minus negative sign outside 1 minus cos square x the whole divided by cos square x dx. That is equals to, take the negative sign inside, you get cos square x minus 1 divided by, I split the fractions, cos square x and cos square x. Simplifying ahead, we get, here one term gets cut, cos square x by cos square x is 1. So we get cos square, which is 1 here, minus 1 by cos square x is secant square x. 1 by cos square x is secant square x. And guys, what is 1 minus secant square x? We don't have any formula. So what we can do here, we can directly go ahead and find what is our what is the integral of this particular 1 minus secant square x. Integral 1 dx is x. You can take a step if you want. I am separating it. Integral 1 dx minus integral secant square x dx. Understood? So, what do we get? Okay, let us see what do we get here. Integral 1 dx is x minus integral of secant square x. It's also direct formula it is, which is our tan x. Okay, but we got to apply something called constant of integration given by k1 in this case. I will not assume c, instead of that I will take k1 in the first case and k2 in the second case. That is our a dash. Integral of a dash dx is nothing but a. Therefore, this is our a of x basically, which is nothing but a. Got it, guys? So, similarly, we will find using b dash formula, we can find what is b. So, this is equal to what is our y1? Y1 is cos x. So, cos x into phi of x secant x tan x whole divided by Wronskian. Wronskian value is w, that is 1. So, this is equals to cos x into secant x is 1 by cos x into tan is sin x by cos x. Otherwise you can keep it as it is if you want, because we can directly integrate only tan x. These two get cut. Now integral b dash dx is equal to integral tan x dx. And we have a formula for integral tan x. What is that? Log of secant x plus c. Instead of c we have k2. So now that you got a and b values, this is our b of x. Therefore b of x is equals to log secant x plus k2. Now that we got our a and b, we can give the final solution. What is that? Which is given by, therefore the final solution, which can be called as a complete solution, is equal to, I have, what is that? Here I have written c, a of x cos x plus b of x sin x. Instead of a of x, we will write x minus tan x plus k1 into cos x plus b of x is log of secant x plus k2 times sin x. Understood, guys? So this is in terms of log x and cos x and sin x. So you can open the brackets, take the multiples. So we get k1 cos x plus k2 sin x, k1 cos x plus k2 sin x. First we will write cos x and sin x, that is individual k1 and k2 terms. Next we have x cos x, so plus x cos x as it is. Alright, next we have minus tan x into cos x. So minus tan x into cos x. We can actually simplify that. Tan x into cos x is equals to tan is sin by cos into cos x. You can see both cos gets cut. So you are going to get just sin x. So minus tan x into cos x can be directly written as minus sin x. Understood? Next, so the last term here, log secant x into sin x, it cannot be simplified. So we can write sin x into log of secant x. This is the final complete solution. Understood, guys? So this is the procedure of finding a complete solution using the method of variations.